Hello everyone! In this lesson, we will learn the basic concepts involved in Internet TCP/IP protocol socket communication between robots and PLC. First, let's learn about the overall architecture of robot workstation communication. Since the production equipment in industrial sites involves various types of modules, data communication between these modules usually uses a bus topology to connect them. A data communication bus is a common communication trunk for transmitting information between various functional modules in a device. The bus is like a train, and the data is like the passengers. In this workstation, Internet cables are mainly used to connect the data interfaces between modules, and the data is transmitted through the network cables. This system network architecture of a typical workstation is shown in the figure. In this network architecture, communication between the robot and the PLC uses Internet TCP/IP protocol socket communication. Okay, everyone, let's go through again the communication methods between modules in the workstation in detail. The PLC communicates with the automated warehouse using the Internet Modbus TCP protocol. The automated warehouse sends I/O signals to the PLC through a Modbus TCP communication module. The PLC communicates with the working axis and positioner modules through the Modbus RTU protocol. The PLC communicates with the HMI and convex camera through the Internet Profinet protocol. The PLC controls the rotation of the rotary feeding unit by sending a pulse and direction signal. The RS-422 expansion module of the PLC reads and writes data from the RFID module. Next, let's focus on learning the TCP/IP communication protocol. First, let's understand the OSI, Open System Interconnect Reference Model, which is the Open System Interconnection Model. This model was a network interconnection model developed by the International Organization for Standardization in 1985. It defines a 7-layer framework for network interconnection. The application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Now, let's introduce the functions of each layer from top to bottom. Application layer provides application interfaces for computer users and various network services to complete various tasks that users want to accomplish on the network. Presentation layer acts as a translator between applications and the network. It provides functions such as data representation, security, and compression for the application layer to ensure that data sent by the application layer of one system can be recognized by the application layer of other system. Sanction layer, responsible for establishing, managing, and terminating communication sanction between presentation layer entities. The communication at this layer consists of service requests and response between applications in different devices. Transport layer provides reliable and transparent end-to-end data transmission services, including handling error control and flow control. The TCP and UDP we often mention are at this layer. Net layer, its main task is to transmit package from the source to the destination. It selects appropriate routes and switching nodes, establishes connections between two nodes through IP addressing, and ensures that data is transmitted correctly to the destination according to the address. This is the IP protocol layer we often refer to. Data link layer provides reliable transmission over unreliable physical media. Physical layer, the final transmission link for signals. This layer defines the standards for physical devices. Its main task is to provide a reliable environment for data transmission, providing transmission media and interconnection devices for data communication between devices to ensure that raw data can be transmitted over various physical media. Next, please answer this question. What is the main function of an IP address in TCP/IP communication? A. Identify the only physical device on the network. B. Distinguish different applications on the same device. C. Provide error control at the data link layer. D. Ensure that data packets arrive at the destination in order. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is A. Did everyone choose the right answer? Okay, let's keep going. The TCP communication model evolved from the OSI reference model. It combines the application layer, presentation layer, and session layer into a single application layer. It combines the data link layer and the physical layer into a network interface layer, thus dividing the network into 4 layers. Application layer allows access to network resources. Transport layer provides reliable end-to-end error and flow control to transmit data packets from the source address to the destination address. Network layer provides network interconnection. Network interface layer responsible for data transmission between two devices on the same network. Socket sits between the application layer and the transport layer. It's an intermediate software abstraction layer for communication between the application layer and the TCP/IP protocol suite. It hands the complex TCP/IP protocols behind the socket interface. For users, they only need to operate the ports and let socket organize the data to comply with the specified protocol. Next, please answer this question. What is the role of a socket in TCP/IP network communication? A. Provide data transmission at the physical layer. B. Responsible for frame encapsulation at the data link layer. C. Serve as an interface between the application layer and the TCP/IP protocol suite. D. Manage IP address allocation at the network layer. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Just like the socket of a telephone, users don't need to know how the information is transmitted. As long as the phone is plugged into the socket, it can be used. You can imagine a socket as making a phone call. The phone number is the IP address, the port number is who you are calling, and the TCP protocol is like the language you are speaking, dialect or Mandarin. Next, please answer this question. We're using a socket for network communication. What information does the client need to know about the server to establish a connection? A. The physical address of the server. B. The MAC address of the server. C. The IP address and port number of the server. D. The operating system type of the server. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? In this lesson, we focused on learning the communication principles of the TCP/IP protocol and socket, including the OSI model, TCP communication model, and the role of socket. That's all for this lesson. Thank you for watching.